At 7:17 in the morning on June 30th, 1908, high above the remote Siberian taiga, the sky literally split in two. A column of bluish light, nearly as bright as the sun, streaked toward the Tunguska River. Then came the flash. A fireball detonated in the atmosphere with such intense luminosity that it was visible from 800 kilometers away. Seconds later, the shockwave arrived. The sheer force of the pressure blast knocked people completely off their feet and shattered glass windows hundreds of miles from the epicenter. That wave kept traveling. The physical disturbance was powerful enough to register on scientific seismographs across the globe, reaching all the way to England. A brief explosion in an isolated Russian forest had generated a planetary-scale physical footprint. Scientists immediately knew they needed to investigate what had hit the Earth, but reaching that remote epicenter took almost 2 decades. Because of the region's extreme isolation and the massive geopolitical disruptions of the First World War and the Russian Revolution, scientists didn't actually reach the site until 1927. When they finally arrived, they found a staggering landscape of destruction. Exactly 2,150 square kilometers of Siberian pine forest had been completely flattened. An estimated 80 million trees were knocked down. When investigators mapped the fallen timber, they realized the trunks were lying in a distinct radial pattern, all pointing directly away from a single central location in the sky. Yet, when they walked to that exact epicenter, they found absolutely nothing. No crater in the ground, no meteorite fragments. Modern estimates place the energy released by the explosion between 10 and 15 megatons of TNT. That makes the blast hundreds of times more powerful than the atomic bomb dropped on Hiroshima. To put that in perspective, if an object of this exact scale detonated over a modern metropolis like London, the resulting force would obliterate virtually everything inside the M25 motorway and kill millions of people. Investigators were left with a stark physical paradox. A localized event possessing apocalyptic destructive power had somehow struck the Earth without leaving a single piece of the weapon behind. The total absence of an impact crater frustrated researchers for decades. It spawned a wave of highly speculative theories, with people blaming everything from rogue experiments by Nikola Tesla to alien spaceships and miniature black holes. Today, the scientific community relies on physical modeling to provide the consensus answer. Tunguska was the result of a meteor airburst. Based on the damage radius, scientists estimate the incoming object was a rocky asteroid, roughly 50 to 60 meters in diameter, about the size of a 20-story building. It entered the atmosphere traveling at approximately 27 kilometers per second. At that extreme speed, the air directly in front of the asteroid doesn't have time to move out of the way. It violently compresses. This compression rapidly heats the rock to such extraordinary temperatures that its structure simply fails, causing it to explode in the sky. This mid-air vaporization unleashed enormous energy downward, flattening the forest below. Because the rock itself was entirely destroyed miles above the ground, there was no solid mass left to gouge a crater into the Earth. The Earth's atmosphere acted like a massive, invisible wall. It turned the asteroid's own incredible velocity into the very mechanism that destroyed it. While the main body of the rock vanished, the explosion did leave physical evidence behind. Researchers discovered tiny silicate and magnetite microspheres embedded deep in the Tunguska soil and scattered inside tree resin. This chart graphs the chemical composition of those microscopic fragments. The nickel-to-iron ratio perfectly matches the established baseline for extraterrestrial bodies. Mapping the destruction reveals a distinct geometric butterfly shape, confirming the airburst traveled on a trajectory from the southeast to the northwest. There is a competing theory that the object was actually a comet. This is supported by reports of abnormally bright, icy skies across Europe for days after the blast. However, the physical recovery of those silicate microspheres heavily grounds the mainstream consensus on a stony asteroid. In the end, it was microscopic chemical signatures hidden in the dirt that provided the definitive proof to solve a mystery spanning thousands of square kilometers. Any lingering doubts about the mechanics of an airburst were erased on February 15, 2013, when a scaled-down version of the exact same phenomenon played out in the skies over Chelyabinsk, Russia. The Chelyabinsk meteor was heavily documented on dashboard cameras. We know it was roughly 20 meters wide, exploded at an altitude of 30 kilometers, and released 500 kilotons of energy. Scientists used this precise modern data to refine their historical models of the 1908 event. Based on those calculations, astronomers estimate that an object the size of the Tunguska asteroid impacts Earth roughly once every few hundred years. This statistical reality turned a century-old cold case into an active planetary threat. Recognizing this ongoing hazard, the United Nations officially established International Asteroid Day in 2016 to coordinate global awareness. And we are moving beyond awareness. In 2022, the NASA DART mission deliberately crashed a probe into the asteroid Dimorphos, successfully altering its orbital trajectory. The flattened trees of Tunguska served as a vital warning. It pushed humanity to develop the theoretical capacity to actively defend our planet, rather than passively waiting for the next impact. Next time, we turn our attention from the skies to the railroads and to the story of Cornelius Vanderbilt. We'll explore how the son of a modest ferry operator used ruthless monopolization tactics to become the wealthiest and arguably most powerful private citizen in American history.